So in this video, I'll be deriving the Rashford-Rice equation for an n-component flash calculation at a given temperature and pressure. So to start off, I'm just going to start with a little diagram of the situation where we need the Rashford-Rice equation. So there's going to be a feed going into a flash drum and in this flash drum our component will be separating into liquid and gas. Inside our flash drum, like so. And then one more thing is that we will know the temperature and the pressure in this drum. Now we can start writing some equations. So our flash tank here is kind of working as a separating process where the flow rate from the feed is being separated into a liquid phase and a vapor phase, and then exiting the tank. So one thing that we know is that the flow rate of the feed, T, is going to be equal to the flow rate exiting of the vapor phase plus the liquid phase. So again, in this situation, we're going to be dealing with a component of toluene and benzene, just like the last videos. So we are going to know the mole fraction of benzene is Z1. So we can represent the moles, we can do a mass balance with the moles of the feed coming in as T, the flow rate, times C1, the mole fraction. And then we can do that same thing for the vapor and liquid phases as well. So it would be V, and this time times X1, the mole fraction in the vapor phase, and then plus L times Y1, the mole fraction in the liquid phase. So now is when we can incorporate what we learned in the last few videos about Raoult's law. So Raoult's law is Xi times the pure saturation vapor pressure, and that is equal to the mole fraction Yi times its pressure. And there's one more thing that we can use that will help us eventually derive our Rashford-Rice equation. And what that is going to be is that we actually have a variable, k, that represents the ratio between the two mole fractions. And from our Raoult's law equation, we can also tell that this will also be equal to the ratio of our pressures if we just divide through as well. And this will become useful soon when we are deriving our Rashford-Rice equation. So now, one thing that we know is that the sum of our mole fractions Yi minus the sum of mole fraction Xi is going to equal 0. And that seems pretty obvious, since let's say we had like 30% and 70% over here, and like 70% and 30% over here. It would obviously just be 1 minus 1 equals 0. So that's just to prove to you that this is in fact true. And then now we can perform a few substitutions in order to get our Rashford-Rice equation. So one thing that I can see right off the bat is that for this yi, we can substitute in a ki, which would just be xi times ki equals yi. So we can substitute that in. So we'll get the sum, and the sum will be k I times xi minus xi, and that'll equal 0. So now we're going to want to substitute something in for this xi, and to make this a bit simpler, I'm just going to factor it out here. So it'll be xi and then ki minus 1 will equal 0. And how we're going to substitute something in for xi is using this equation here. And actually, I noticed that there's a little mistake here in this equation. Our xi is supposed to be the mole fraction for the liquid, and y is for the vapor. Y here and xi here. So what we're going to do is we're going to use this equation, but again substitute our k in. So how's that going to look like? So it's going to be, again, just t zi on the left side will equal v, and this is where we're going to put in ki times xi plus l xi. And now we can factor out our xi. It'll be t zi will equal xi v ki plus l. And now to get even less variables in this equation, we can use this equation to substitute t minus v will equal l. So t zi will equal xi v ki plus t minus v. And now finally we can divide this to the other side. So we'll have t zi over v ki plus t minus v, and that will all equal xi. And one last thing is we can factor out this v. It'll be t ci over v ki minus 1 all plus t, and that will equal xi. Finally, this is where it gets a little bit complicated, but what we can do actually is multiply this, both the top and the bottom, by 1 over t. And what will that give us? So it will give us zi over v over t ai minus 1 plus 1 will equal xi. And now we can finally substitute that back in to our sum over here to get our final Rashford-Rice equation, which will be k I minus 1 multiplied by zi over, or v over t, ki minus 1 plus 1. And that is signified by we'll make it simple. So this is our final Rashford-Rice equation. And one last thing that I forgot to mention was that we will have our bounds for our summation z on top here, and then I equals 1.